Good morning once again. Thanks for watching. So this should be a very quick video, and I'm going to demonstrate the opcode instruction SWAPF. And what you do in that instruction is you end up swapping nibbles in a file. What's a nibble? It's the first 4 bits in a byte, or perhaps the last 4 bits in a byte. The first 4 most significant bits, the last 4 least significant bits. And this instruction will just swap the two. Someone told me that puns are not funny jokes. They told me to stop it, or should I say swap it. So today I'll be using the opcode instruction SWAPF, which swaps both nibbles in a file, and I'll get through this quickly. So these equates are used for the delay routine at the end. Here's the delay routine. I shortened the delay routine by changing the inner loop value that gets loaded up to a smaller number. It was FF before, so I put it to roughly half, so the delay is shorter. The only reason I'm using a delay in this code is to debounce my push button switch. I'll get to that. So these equates are for the delay routine, subroutine. This helps set up my chip. Port D is an output, port C is an input. We don't even need port B anymore. So I initialize port D by putting this number in, where the first 4 most significant bits are all 1s, and the last 4 least significant bits are all 0s. And I move that value into port D 1 time, and the code does not return to this section. Now here's my main bit of code, which basically is monitoring input bit pin I designated, which is RC0. It has a pull down resistor connected to the push button, so when I push the push button, it receives a high signal, and the signal goes from low to high, and that's plugged into the female header on pin RC0. Port C is an input port because I set it up that way. So the main code is going to bit test the file skip if clear. So it's going to wait until RC0 receives a high signal or a set signal. In the resting state where it's clear, the button is not being pushed, it will skip this next line of code and go back to main and just continue iterating here, waiting for me to push the button. But once the button is pressed and a high is received into RC0, then it won't skip the next instruction. It'll go to the next instruction, and that instruction is go to and then swap it. That's the label I gave, which first of all calls the delay routine, which really is just here to debounce the switch. And a trial and error made me come up with this number. Then I swap F, so I swap both nibbles. So I loaded up port D with this value, so it'll swap all the ones with all the zeros. And then once it swaps it, it goes to main again to check if the button is being pressed. If I hold the button down, there is a little delay set up here, so quickly you'll see everything swap back and forth.
Alright, so here's RC0 there. It's connected to a push button with a pull down resistor to ground. When I push the button, it receives a high signal and it sends it into RC0, port C having been configured as an input port. And the code I already explained, SWAPF, will swap the nibbles stored in port D, and it was initialized in this state it's in here. So if I push the button once, it swaps everything. Push it again, and I can hold it down. Thank you for